in SageMaker. Before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, SageMaker K-Means is a scalable implementation of the classic clustering algorithm built for unsupervised learning at web scale. It groups similar data points into K distinct clusters without requiring labeled data. This is a fundamental difference from K nearest neighbors, which is supervised. So K-Means identifies structure by learning from features alone, assigns observations to clusters based on similarity, typically Euclidean distance, and it outputs both clusters centers, these are centroids, and labels for each input point. SageMaker optimizes this for massive data sets using shared data ingestion, multi-node parallelism, and enhanced initialization strategies. So how does this work? All right. The algorithm represents your data in an n-dimensional feature space. It starts by selecting K initial cluster centroids using K-Means++, which chooses well-separated starting points to improve convergence. Each data point gets assigned to its nearest centroid, then centroids are recalculated as the mean of all points in their cluster. This assignment and recalculation repeats until centroids stabilize. SageMaker adds several enhancements to this basic process. It includes big K, calculated as K by extra center factor, right? Multiplied by extra center factor. So this creates a temporary cluster during training that improves convergence. This mini batch learning accelerates training on large data sets. The implementation uses Lloyd's method for efficient distance calculations and is optimized for pipe mode with shared S3 file input. An optional test channel lets you measure clustering evaluation metrics as well. So how do we configure this? All right, so the hyperparameter determines, all right, good. So the hyperparameter is going to determine how, oh, this is the wrong one. Okay, how you're going to do your output, right? So you use the elbow method to identify optimal values. Oops. Optimal values, you plot the within cluster sum of squares against the different K values and look for the elbow where the improvement diminishes, all right? From here, the extra center factor will control how many temporary clusters the algorithm uses. The higher values can improve results, but increase computation. For large data sets, you're going to have to choose the mini batch size to control how much data processes in each iteration. And then you'll set epochs to control how training passes over your data. And we'll go into that when we go forward into the actual console, right? And K-Means requires a train channel with unlabeled data and an optional test channel for clustering quality evaluation. For inputs, you're going to need either CSV or record IO protobuf with both file and pipe mode supported. And then for distributed training, you can use a shared by S3 key distribution for your training data to split it across instances, and fully replicated for test data to ensure each instance has the complete test set. So let's get into SageMaker AI. Remember, everything has to go in S3 first. You go down to training jobs, click create training job. K-Means test. Select the IAM role that's appropriate. It's defaulted to the SageMaker built-in. That's what we're using. K-Means clustering. All right. Select file or pipe mode right here. And you can select your instance type. So it defaults to training on the ML CPU style. So you could do the ML M5, ML C5, which are cost efficient for medium-sized data sets, right? And you go to the GPU sizes, which are MLP, right? This would be the 2x large, 4x large, or 2x large, 8x large to accelerate training. Though each instance is limited to one GPU. For model hosting and light inference workloads, you can go for the MLT. These instance types, the T3 instance types. Okay, and you can save costs by using pipe mode with sharded training to scale across nodes without memory overload. That approach will handle massive data sets efficiently while keeping infrastructure costs reasonable. All right. So common applications would include K-Means would be good for discovering natural groupings in data, right? Marketing teams could use it for customer segmentation. Retailers could apply it to market basic analysis. And then recommendation systems could use it for user behavioral grouping, right? Computer vision could use it for image compression and features extractions, and a security team could use it for anomaly detection by identifying outliers that don't fit established clusters, right? So the algorithm is very available for machine learning pipelines, and it's good for structure, dimensionality reduction, or preprocessing for downstreamed supervised tasks. All right. So we go in here. What do we say? We were going to set the K value. So set that to 5. Mini batch size 5,000. We'll set that for good here. And then what else do we want to do? I think those are the primary ones. Epochs, yeah, 1. Let's go for 3. All right, and then evaluation metrics, K-Means, that's good. All right, then you remember here, you set your training, you set the file type. Okay. Since we picked the record IO protobuf, we got that. S3, enter that S3. Okay, the checkpoint in case you wanted to have the spot instances. Output, key value pairs, which you needed for your team. Click create training job. Boom. All right. And so from here, you'll be able to monitor your outputs in the SageMaker dashboard, or you'll be able to look in CloudWatch logs. All right. Once training is complete, you can create the model from your artifacts and deploy it to a real-time endpoint. And this will let your cluster use new data points by finding their nearest centroid. Okay, we're going to get cancel. Already gone over some of this. Okay, so K-Means integrates throughout the ML work stack for AWS, right? S3 stores your data. SageMaker pipelines automates experimentation. You can also use Athena and Redshift to pre-process structured data before clustering. And QuickSight can visualize the clusters with the scatter points, heat maps. We also talked about CloudWatch logs, and you can have the human in the loop, where you have the Amazon A2I to have humans review the clustering outputs when you need validation. All right. So for the certification, remember a couple of essentials. K-Means is unsupervised. It discovers structure without labels. It differs from K-nearest neighbors, which is supervised. K-Means plus is the initialization that improves convergence over random initialization. SageMaker uses big K with extra cluster centers during training. Sharded training enables multi-node parallelism on large data sets. The K parameter determines the cluster count. So use that elbow method to optimize this. The GPU training is an option, and it is optional, but you can limit it, but it's limited to just one instance, right? You should probably stick with the CPU unless needed. And then common use cases would be segmentation, pre-processing, and anomaly detection. So when you're taking the exam, any questions about unsupervised clustering, discovering natural groupings, or customer segmentation without labels, K-Means is your answer. So that'll be all for K-Means. Thank you for joining. Have a good day. But before you go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Have a good day.